Hi everyone, thanks for coming to the first tutorial on Max Diceman about the map generator. First I want to say that today was exciting because I got Max Diceman demo released on Steam. So you can see it in Steam now and download the demo, and if you're ready for a challenge, give it a try. So today I'm going to talk about our map generator. What I did is loaded up this old file from about 2 months ago from April 15th, and this was right after I completed the map generator tutorial. So this tutorial, first want to give a big thank you and shout out to this Binding of Isaac map generation in Unity tutorial from the awesome developer and tutorial content creator Game Dev Garnet. So I will be leaving a link to this tutorial in the description because this was critical for learning how to make a map generator, and anyone wants to learn more about how it's made, this has a great tutorial, and there's 3 parts to it where you can really dig in deep to find out how it works, and then also create bigger rooms and different things that you can do with the map generator based on Game Dev Garnet's Binding of Isaac map generation tutorial, which is excellent. So I'm going to recommend that and link that. Go ahead and pop over there and check it out and give a like or subscribe if you want. So over here we've got the map builder in Unity, and just quickly I'm going to go through the components that are going to make up the map, which is a cell prefab. So over here we've got a cell prefab, which is just a game object with a cell script on it, which we'll look at in a minute, which references this sprite renderer, which is just a sprite of gray dirt that I have, 32 by 32 sprite, and then the pixels per unit are set to 64 and single. Something to note that you would want to, that I found out later, change this for any pixel art to filter mode with point, no filter, and none on compression. That way you'll get a clearer pixel art picture. So once we have our sprites set up, you can see over here I have a sprite for a boss, for a treasure chest, a secret room, a shop, and a starting room, which are all the same thing, 32 by 32 pixels, little sprite there. And then once you go into the map builder, you can see I have those sprites referenced here, those same ones I showed you there. I've got some integers that are public for minimum and maximum rooms, and then a player to spawn and a game camera to follow that player. And down here I'll mention I've also got some enemy sprites, just 2 there, so that you can have multiple enemies appearing within the level. And the same thing there with the sprites, it's just a 32 by 32 and popped an enemy on that gray dirt background. So now that we've got the components of this map builder, we'll go ahead and look at the scripts. And I'll go ahead and do this slow so you can take what you need from there. But cell, it's pretty simple. It's just got an int for the index, which is keeps track of locations. In vector 2, also the location, and the revealed, that will tell us if the square is revealed or the cell is revealed or not, and that's for the darkness effect, and then like a fog of war effect essentially. And then set special room sprite. This is what if there's a enemy or a boss or a special room, this is what's going to set the sprite icon. So to the map builder, let's take a look at that, and I'll go slowly through the script here again, so you can capture what you need. Also, if you go to the Garnet Game Dev tutorials, you can definitely go step by step through those tutorials to get what you need here. I'm going to go a little more quickly and just explain everything we have here. We have indexes that are vector 2s for each room. Our boss, item, secret, shop, and start. And then an array for the enemies, because I want to have more than one enemy. We have our cell prefab, the cell size, which I can explain, and which is basically depends on the size of your sprite that you're using. The cell queue will keep track of cells that are spawned, and then some other settings in here. You saw before the minimum and maximum rooms, the list of enemy rooms and end rooms, which we'll see at work below, and then the grid size. The grid size can be adjustable so that it doesn't have to be a 10 by 10 square. You can do different sizes. We've got our game objects that we explained below, such as our player, and then our sprites for our rooms. So when the script starts, it's going to set the cell size because using the sprites that I have, 32 by 32, the cell size needs to be half the size. You can change this depending on the sprites you're going to use. You'll want to use powers of 2, of course, probably no smaller than 16 by 16, but 32 by 32, 64 by 64, 128 by 128, and so forth, and set the cell size accordingly. After that, it's going to initiate the map, or init map, and first it goes through here. It's going to destroy all the spawned cells if there's any spawned, and it's going to clear that array out. And then for the floor plan, it's going to make a new floor plan based on the grid sizes. It's going to set the enemy room indexes based on the enemy's length, so based on how many enemies that you put in the array. Remember, over here we had 2 enemies. So for that array, based on that array length, it'll create enemy indexes, and then floor plan count, cell queue, empty rooms, end rooms. These are all used as we spawn and create our map below. So you can see we've got a while statement that's going to queue through each cell until it's over. The queue's over basically until it's while it's greater than 0, it's going to keep executing this loop. Once the queue is 0, it will stop. Within the queue, it's going to dequeue the cell first, and then you'll get the indexes, and then here is where it does its magic of finding the cell and then creating one adjacent to it, depending on whether it has been created before, whether there's an empty cell or not. It will then add it to the index. It will add the index, which again is just the location X and Y of the vector 2 to the empty rooms list. If it wasn't created, then it's going to say, oh, that's an end room, like an end of a hallway, and it'll add it to that array instead. So again, if you want more info on how this magical piece works, check out those Garnet Game Dev tutorials. Anyway, if this last part, if the floor plan count is less than minimum rooms then set, then it's going to initiate the map again. It's going to do it again because it's not big enough. And then if it doesn't, if it skips that and it doesn't initiate the map again, if everything's looking good, it's going to say, okay, let's initiate the special rooms. We'll go through here, and it first is going to find an end room for the boss and assign that. And then it's going to multiply that value by 0.5 just to get it in the right location on the map. That might change depending on the sprite size you're using. For enemy rooms, it's going to find a random empty room for each enemy on the list. Then for the item room, in the shop room, it's going to find another random empty room. Secret room has its own special script I'll show in a minute. And then start room, it has get a random end room. So these get random end rooms or get random empty rooms, these are special scripts I'll show below that can find rooms that are empty for your bosses or enemies or what have you. Now if none of the rooms got assigned, let's say boss room is null or start room is null, it's going to do the map again. It's going to create it again. There's also a vector distance in here to say that if the boss room is too close to the start room, let's recreate the map again. So it's going to keep recreating the map until all the conditions are perfect. Once it is, it'll spawn the player at the start room, and it'll spawn the secret room, and then it'll update the special rooms. And what that does is just that. It takes each special room, it goes to the cell, and it sets the room sprite. So whatever the room sprite is for item, shop, boss, etc., it's going to set that sprite on that cell. Okay, for enemies, it's going to go through the loop of an array of enemies and set a special room, an enemy sprite from the array of enemies for each enemy cell. Here's the get random empty room and the get random end room, and you can see how those work. Essentially, they go through the list of cells, they find the index, and find the last empty room or the last end room that was made, assign that and return that as the empty room index, and then just remove that from the list. You get secret room. It's a little more complicated. It loops through, and you can set the iterations to higher or lower, but it's essentially going to try to meet each of these conditions and then return an index that qualifies as a good secret room. And you can adjust these to so there's a certain number of adjacent rooms for the secret room, or maybe it's too close near the boss room, or different conditions here. Like I said, that it will loop through, and once the conditions, all of them are met, it will return an index. Otherwise, it will return null, which means you'll get no secret room. So if that's happening, you might increase that iteration or adjust your conditions here. Get adjacent count does that. It gets the count of rooms adjacent to the cell that you're asking about, or the index. The go to cell goes to the cell that you need, and then there's some other auxiliary scripts down here that I'll go through slowly so you can check out. Spawn room does just that. It spawns a room at the cell or index location. And then the spawn the player here, that spawns the player, and down here is the fog of war that I have commented out for now. So to see this in action, we'll go ahead and hit play. And you can see I've got 10 rooms minimum, 20 maximum. So it's making a small little map here. And I'll go ahead and show you. It's got different maps here. The small amount of rooms. We can increase that. Let's do maybe 90 and 70. And then we can see now we've got 75 rooms were spawned. And if we pull out the main camera here, you can see the map can get pretty complicated. But it has some good maze qualities, and if you want to get more complicated with bigger rooms or different things like that, or different kinds of rooms or more enemies showing up, you can definitely take that script and what I've shown here and expand it. But hopefully this wasn't too long and got you what you need to make your own random maps. All right, thanks a lot.